Hello students, welcome to the math class. Students, in the previous class we have started with the chapter Binomial Theorem and we have completed its first two objectives. First, introduction and basics. Second, expanded forms of a plus b raised to power n and a minus b raised to power n. Today, we are going to start with its third objective, that is applications of binomial theorem. Now, let's start with the third objective, its application. So, in first example, using binomial theorem, evaluate under 3 plus 1 raised to power 5 minus root 3 minus 1 raised to power 5. Here we have to use the binomial theorem. We can apply here because there are only two terms and raised to power is 5. So there are two terms. First is a plus b form, second is a minus b form. So in both the cases, firstly we will apply the binomial theorem. So we'll start with the first. It is 5c0, then 5c1, 5c2, 5c3, 5c4 and 5c5. We have written the binomial coefficient. Now, next start with the first term, that is a. As we know, power of a goes on decreasing. So, first term is root 3 raised to power 5, then root 3 raised to power 4, root 3 raised to power 3, then root 3 raised to power 2, root 3 raised to power 1, and in the end its power is 0. Now look at the second term here. Here second term is 1. As you start writing 1 as a second term, it will not affect because 1 raised to power, any power is always is equal to 1. So then all are having plus sign because it is of the form a plus b raised to power n. Now second is there. Firstly put the minus sign outside the bracket. Then apply the theorem in the second. So it is root 3 minus 1 raised to power 5. So same terms will be there like this. And only the alternate sign will change. So first term we are going to start with plus, minus, plus, minus, plus, minus. In this way. Now, when you open the bracket, outside sign is minus. So, it will change the sign of the inner terms. Look at the next step. First term written as it is with the plus sign. Now, after minus, first term will become negative. That is minus of 5c0 into under root 3 raised to power 5. Then here minus changes to plus. Plus changes to minus, minus changes to plus changes to minus and minus changes to plus. Now, you can see these two terms are same but their signs are different. So, we can cancel these terms. Similarly, both are having plus sign, so we can't cancel. Here, third term having opposite sign, so we will cancel this one also. Next, 5c4 under 3 raised to power 1 and here it is minus 5c4 into under 3 raised to power 1. These terms will also cancel out. Now, we are left with three type of terms. 5c1 into under 3 raised to power 4. Second is 5c3 into under 3 raised to power 2. And last one is 5c5. So, write it down like this. So, it will become 2 times 5c1 into under 3 raised to power 4 plus 5c3 under 3 raised to power 2 plus 5c5. Now, these are the binomial coefficient. We can find its value by using the formula of NCR. It is equal to n factorial upon r factorial and n minus r factorial. Now, first is 5c1. So, 5c1 can be calculated 5 factorial, 1 factorial into 5 minus 1 is 4 factorial. So, on simplifying, we will get 5 into 4 factorial upon 1 into 4. Here 4 factorial cancel with 4 factorial. So we are left with 5. Similarly, 5c5 is there. So here n is 5, r is again 5. So on applying the formula, we will get 1 because 0 factorial is always equal to 1. Next 5c3 is there. Again same thing. N is 5, r is 3. So 5 factorial upon 3 factorial into 2 factorial. So when you solve 5 factorial, it will become 5 into 4 into 3 factorial. Here 3 factorial cancel with 3 factorial and 2 factorial can be written as 2 into 1. So answer is 10. When you put these values, you will get 2 into, here 5c1 will become 5 and 5c3 will become 10. 5c5 will become 1. And under 3 multiply 4 times, we will get 9. Under 3 multiply 2 times, we will get 3. So when you multiply, you will get 9 5s are 45. Here 30 plus 1. So on adding, we get 76. And on multiplying with 2, we will get the answer, that is 152. In this way, we can apply binomial theorem to solve these types of sum. Let's take one more example of the application. Using binomial theorem, prove that 3 raised to power 2n plus 2 minus 8n minus 9 is divisible by 64 for all natural numbers n. Now, we have to show that it is divisible by 64 but using binomial. Same type sums we have done in mathematical induction also. But here we have to use the binomial. And for using binomial, we need binomial terms with the power. So here, look at the term which is having a power. So only first term is there which is having power. So first term we can take 2 common and write it as like this. So firstly statement 3 raised to power 2n plus 2 minus 8n minus 9. Then take 2 common, it will become 3 square. So 3 square is equal to 9 raised to power n plus 1 and last 2 terms as it is. Now 9 can be written as, we have to break it into the 2 terms. So 9 can be written as 1 plus 8 raised to power n plus 1. Then minus 8n minus n. Now here we will apply the binomial theorem. A is equal to 1 and B is equal to 8 and power is n plus 1. So start applying the theorem. So here first term is n plus 1 c naught plus n plus 1 c1, n plus 1 c2 and plus so on till n plus 1 c n plus 1. Now first term is 1. So when you decrease the power by 1 till 0, you will get same terms because 1 will not affect the value. So now let's start with the second term. Increase the power by 1. So first term is 8 raised to power 1, 8 raised to power 2 and so on. We will get 8 raised to power n plus 1. No need to write all the terms. And last 2 terms as it is, minus 8n and minus 9. Now you can see n plus 1 c naught is always equal to 1 and n plus 1 c1 is n plus 1. You can find it by using the combination formula. And here 8. The next one is n plus 1 into c2 into 8 square. Now 8 square will become 64. Similarly, other terms will continue. Next term will contain 8 raised to power 3. So again 64 is there and so on. Last one is 8 raised to power n plus 1. Now you can see when you solve it, you will get here 1 and when you open the bracket 8n plus 8. So it will become 9 plus 8n plus here. From the further terms, we will take 64 as common. So write out the left out terms. It is n plus 1 c2 plus n plus 1 c3 and 1 8 will left plus so on. the terms will be like this. And last two again same. Now you can see here minus 9 will cancel with the plus 9. Minus 8 will cancel with the plus 8. Now look at the left out terms. We are left with these term only. That is 64 multiply n plus 1 C2 plus n plus 1 C3 into 8 plus so on. Now from here, when you solve it, we know that we always get some integer. So form becomes 64 into some integer. So we have shown that 64 is a common factor. So the full expression is divisible by 64. Therefore 3 raised to power 2n plus 2 minus 8n minus 9 is divisible by 64. Now students, I hope you got the topic now how to apply the binomial theorem in the statement sums. Before starting the worksheet given in the SNAP homework, you must go through the links guided in the SNAP homework. Rest we will continue in our next class. Thank you.